Hello and welcome back to another tech video by Design Fusion. My name is Gaurav from Design Fusion. In this video, we will talk about bolt connectors and Solid Edge 2023. The agenda for this meeting would be performing an analysis on basketball rim, use bolt connectors to simulate the hardware, reinforce the structure if required. Here's our model. We have nets, hoop, the support bracket, and our inner holding. It all consists of basketball rim. I've already made a simplified assembly, and this is the configuration. It only has the hoop and the sheet metal parts. Now let's just go ahead and extract our sheet metal bodies. First one would be the support bracket, and the other one would be the inner holdings. As an option, I'll give it a ratio of 0.5. I'll hide this from Pathfinder to avoid any confusion. If I go to my simulation pane, you could see this mid surfaces being created. Now let's go ahead and start our study. The study will be of linear static, and the mesh type would be mixed and general bodies, as we have a combination of solid bodies and sheet metal bodies. Here you could see our study 1 is created. Now let's just prep the model. First I would be putting a constraint in. I'll put a fixed constraint at the back because this will be attached to the rod and the rod would be situated on the ground, so I'll make it a fixed constraint here. Second is the load. I'm going to put load on the back surface, the upper portion, and also on the middle of the hoop. We'll give it a downward direction, and also the load would be 200 pound force, and Solid Edge will automatically convert it to meganewton. Now let's move forward to our last step, which is the bolt connectors. The selection type would be steel. I'll choose the 2 holes which are at the top. Here you could see it has been created, and also the dialog box which represents its specifications such as nut diameter, etc. I'll choose spider and multi bolts. What spider does, it creates a rigid element at the location where 2 holes meet. Now our first bolt connection is done. Let's create other 2. The other bolt connection, in this I will choose the edge of the sheet metal surface. We'll perform the same process. Choose spider and multi bolts, and you could see our next 2 bolts are created. Let's mesh and solve our study. Here you could see the yield stress is 276 and the maximum load is 487, which is beyond. This absolutely is a failed model, but here we're not concerned about failing of the model. The study is something else. If you would see, the maximum displacement is 19.8, but let's just say if we have done it right or not. I have animated the model for you. You could see that our hoop is moving by itself, so it means that we have made an error on our side. Let's fix it. I will now delete our bad bolt connection and create a new one. For a better visualization, I have hidden the other bolt connection as well. This time, rather than selecting an edge, I will select the face, which means that this bolt connector is attached to this face. I'll make sure that spider is turned on, and I'll perform the same process on the other end as well. Bolt connector, choosing a face, turning on the spider option, right mouse button click and click yes. Now you could see our bolt connection has been created. We'll perform the same step. Let's solve the model. Here we have seen the complete change. Previously it was 487 as a maximum stress, but now it is just 314. Now look at the displacement. Displacement was 19.8, but now is 18.5. Let's double check and animate the model. Here you could see that it is fixed. I will now put it into a stress mode and make you visualize a more better. Now you could see that it stays at the point, and you could see the maximum stress over there as well. But still, this is not what we want. Let's try to optimize the model, make some design changes, and see if we could reduce the displacement. I'm gonna make a few changes. The first change would be I'm gonna increase the length of these fins, and also will make it, here you can see the change has been done. First of all, I have changed the material from aluminum to steel, and as discussed, I have increased the length of this fin, and I also have made it more thickened so it could take more load. Let's go back to our study. Solid Edge makes it very easy for us. Rather than going over the study, I would just copy and paste the study and just perform the action. Under Simulation tab, copy my study 1 and paste it under the Simulation tab as well. Here you could see everything's been copied as it was before. Now I'm solving the model. The maximum load is 413, which is still the highest, but like I said, the major concern was with the displacement. We could see a major change in the displacement. It was 18.5 before, and now it only comes down to 6.71. Now at the end, let's just recapitalize what we have learned from this video. We not only have learned how we can take an advantage of our bolt connectors, but we also have learned while using bolt connectors, we should be selecting faces, not the edges. And especially when it comes to mid-surfaces edges, we are not supposed to select them. As we do, we will see the change in our analysis result. I hope this video has helped. I'll see you very soon with another technical video. Bye for now.